Hello there, this is Daniele from Toolchefs, and in this video I'm going to give you a demo of AtomsMaya. So the purpose of this video is to give you an overview of AtomsMaya, how it works within Maya, and to show you some of the main features of Atoms. We're not going to go through all the features. If you have any question or if you want to know more, you can still browse our YouTube channel and look for more videos. Or if you want, you can even send us an email, or you can ask questions on our Google group. Okay, so basically, once you have installed the plugin and also installed a valid license, you can go under Windows and then under Setting Preferences and Plugin Manager. You can search for AtomsMaya, and then once you have found the plugin, you can just load it. So in this case, I've already loaded it. And you would see appearing both the shelf and the menu here. So you see that basically the same stuff that you have in the shelf is also here in the menu. It's just, the shelf sometimes is way easier to use. But anyway, so the first thing, we're gonna work mainly with two main UIs. So the first UI that you need to know how to use is the Atoms UI. The Atoms UI is used for setting up your crowds, meaning registering your agent types and registering your animations and state machines. So you notice that as soon as I clicked that menu action, this pop-up came out saying you need to initialize your scene. So you want always to say yes, because if you press no, it's just basically you'll have to go back here and click again on the Atoms UI, and then the same question will be asked to you. And whenever you initialize your scene, what that means is that you're basically creating this node, which is called the TC Atoms node, which contains all the global stuff, the global information for Atoms. So it will contain a list of your hide fields, the navigation meshes, some simulation attributes. So the start and end frame, you can always use the scene start frame and scene end frame, which is basically the default for AtomsMaya. Then also we have the rendering tabs, where you can provide some variation JSON files reference variation JSON file, because basically when you import JSON files with variation import variation JSON, and the variations again are just the variations for your agent, so it could be like different clothes, different hair, and so on. We've also added this option where you can basically still have your JSON on disk living somewhere. You can basically add a list of JSONs here, and then by just clicking update draw variation data, all the JSON will be sourced again from disk, and then the content will be saved in this scene. Then we have the extra attributes section here, where basically we have the variation JSON data, which at the moment is empty. Again, this is just the data for which contains all the variations for your agents. And then we have the JSON data, which is basically the actual content, the actual JSON that defines all your agent types and animation clips. So whenever you edit anything in the Atoms UI, whenever you click register for any of these assets, the JSON in this attribute is getting saved again. So this JSON here contains all the data that is coming from the Atoms UI. About this node and about these attributes, you don't really need to care if you are not going too technical about all this stuff. This is mainly if you are, if you need to build a workflow for your company or this kind of stuff. Is always useful to know what Atoms is doing. So whenever you change the content of the Atoms UI, you're not actually editing anything which is like on a global level for your old Maya session and so on. You're actually editing the content of your scene. If then you want to export whatever setup you've made here, so for instance, if you create new agent types, new animation clips, state machines, and so on, you can always go under Atom Scenes and then do export scene JSON, or import scene JSON if you want to import a JSON that you have already exported previously, or if one of your colleagues exported that and saved it somewhere. You can also export partial scene JSON, which means you can just export agent types, animation clips, or state machines or behavior tree. So you can just select whatever you want to export and just click export, and that will be exported inside a JSON. Okay, so for the Atoms UI, I'm going to expand it a little. So here you see we have different tabs, and these tabs, they are separate for different assets. So here we have animation clips and agent types, which are the things that we're gonna check first. So for the agent types, you see here we have a list, and here are all the agent types that are available in this scene. So here we have just the man, which is the default character that we ship with Atoms. You can still download our agent bundle, which is on the download page of our website. And here you see this little icon, which at the moment is green, which means that this agent type was loaded successfully. If you see it red, it means that something went wrong. For agent types to fail at loading time, it means that one of the paths basically is pointing to a file that doesn't exist. If you leave all these things empty, all these attributes empty, and you just leave the event name, that will still be a valid agent type, because Atoms doesn't really require for you to provide a skeleton or any geometry. Just because when you don't provide a skeleton, Atoms uses creates like a default skeleton with just one joint. And then if you don't provide any geometry, Atoms just build an agent with just a skeleton. So it's like you can provide all of this stuff, but again, like just to make it clear again, it's just this icon will be red only if any of this path is pointing to a file that doesn't exist anymore. Then on the right here, we have a preview of your agents. So here you see we have a skeleton file, which is pointing to a file on disk. Then we have geo, skin, ragdoll, character, and so character path, state machine, and other attributes here. So whenever you export a skeleton, the skeleton can get exported both with our exporters. So if you have a scene with your own character, and there are videos, we have already videos on our YouTube channel that show you how you can export your characters. You can export your skeleton. It can be in different formats, so it can be AtomScale, it can be FBX, it can be USD. And that skeleton could contain some tags. Some tags means just some attributes that define the structure of this, sorry, not the structure, but more like if a joint is a pelvis, if a joint is a leg, if a joint is part of a leg, and so on. And if you have any basically joint that is one of those, they will have a different color here in the viewport. So you see here we have green, which is like the pelvis. We have blue, which is the foot root. We have the pink one, which is like the foot AK, and then the foot tip is the yellow one. If you haven't set up your skeleton, so for instance, if you bring a skeleton from another application, like it could be character creator from Reallusion, or an FBX coming from Mixamo, or things like that, you don't have to go through all our exporters, but you can provide the path.fbx here, and then start tagging the joints here, and it will be basically the same thing. So you don't really need to go through all that process. Even if you have an USD file for your skeleton or mesh, it would be exactly the same thing. So it's nice to know that, you know, if you have even files that weren't previously processed with Atoms, you can still load them here and tag the joints here. It's important to tag your joints properly, because if you want to have foot locking or, you know, even ground adaptation, it's important, you know, to provide the to tell Atoms which are the legs and which are the pelvises. With Atoms, you can have any number of pelvises. So if you have, for instance, a quadruped or a spider and so on, it's important just to tag the pelvises, so you can have more than one. And in a case of a quadruped, you would have a pelvis which is between the back leg, and then a pelvis which is like between the forelegs. And then for the legs, you would have you would tag like the foot root and the foot AKs and the foot tips and so on. You can also provide skip AKs. And basically the skip AKs are the joints that whenever you have an AK chain, so for instance for the legs, let's say, if you have, for instance, if we had like a joint roll, a roll joint here or here, in order for Atoms not to evaluate it as part of the AK, you would have to tag it as a skip AK. Here we have some which are basically these joints here that you see. So it's basically the left arm and right arm rolls, and the same thing for the right arm rolls and then the left arm rolls. Okay, so now let's look at the animation clips. Same thing here, we have the green icon. Here is a list of all the animation clips that are available. The animation clips is green whenever the file path is actually pointing to a valid path on disk. So if you have like a file that is not, sorry, a path that is empty, or either empty or is pointing to a file that doesn't exist, then you would actually you would find this the icon red. So we added these icons here because sometimes, you know, like you open an old scene, or you open a scene from another person, made by another person, and so on, and then basically you don't see you try to run the simulation, but basically it's not working because some assets are missing. So if you just open that AtomsMaya, you would see straight away which assets are missing by checking the icons here. So here as well, we have the viewport. Also, actually, sorry, I forgot to say, in the agent type, if you right click on the viewport, you have some options here. For instance, you can see the skin mesh, the joint names. Sometimes there are, you know, you can have quite a lot of joints, for instance, in the head, so you would have really to zoom in to see the joint names. You can also see the work position, and this is particularly useful whenever you have to set up your legs and set the pole vector. But again, all this stuff is also explained in other videos, so if you are more interested about how to register agent types, I would recommend to check those videos. For the animation clips instead, you see here we have the clip. If you right click as well, here we have some other options. We see these yellow circles here, and basically whenever you see a circle under a foot, it means that that foot is basically has a foot down state at that frame. So for the idle clip, you see is always down. If we check the walk, for instance, we see that at the moment we have just one red circle, and then you know it appears and disappears for each foot whenever it's down. Atoms needs to know this information if you have feet and legs, just because that basically tells Atoms when to apply the foot locking during the simulation. So the foot down state can be already in your FBX or USD file, but if you don't have that attribute or state already embedded in that file, you can still go in here and provide the foot down state for you know, the different frames. So you see here we have actually, you know, some we have set up the frames for the foot down and so on. You can load them from the clip, or you can compute them depending on the clip and so on. For all the settings here, I would really recommend to, you know, check the other videos again, just because there's a lot of stuff to go through. But it's quite important. Just the main settings are, so the clip path, you have to provide a clip path for sure. You have to provide a blend frames after foot up value, which is basically whenever a foot goes off from the down state. So it means that basically, let's have a look at this right foot here. So basically this frame, you see, is not down anymore. So Atoms will require some frames for blending from during the simulation, from blending from the frame where it was actually locked on the ground to the actual position coming from the clip. So to the actual pose, sorry, coming from the clip. You know, 4 is the default value, but you can provide even more. Then here you can say, you know, if it's a loopable clip or not. In this case, it's a walk. So yeah, it's a loopable clip, and you provide a start and end frame. Usually you would have to provide, if you go a frame 36, so the frame 36 and 70, if I press 70, they should match pretty much. So it's important that the start and end frame of a loopable clip are similar. And then here we provide a loop blend, which is basically the number of frames that Atoms uses for blending from whenever it reaches the end of the clip, from to blend with the start of the clip. Then another important thing is the direction type. So usually you would provide it as a static value, and you would provide like you know, a vector, which basically these tell Atoms how the agent is moving in 3D space. Sorry, not the agent, but how the clip is moving in 3D space. And another two important things are like the man. So the compatible agent type. So in this case is the man. The compatible agent type is actually an agent type here. This is important if you to set, especially if you are planning to use any of the options down here, or if you want to apply a retargeting. And then we have the transition frames. The transition frames are basically telling Atoms when a clip can transition. So it means that basically it doesn't have to reach the end of the clip, because sometimes, for instance, let's say at the man idle, you see we have 300 frames. We don't want to reach until, like, we don't want to get to frame 300 before we can transition from this clip to another. We want to have some in-between frames so that the clip again can transition smoothly into another state. Okay, so these are the main settings. Here we have also options for reversing the clip, so for mirroring, other things for enable perching, foot down, and other stuff which we're not gonna go through in this video. Then here we have the state machines. State machine is basically defining a graph, telling Atoms how an agent or the agents using the state machine can transition from a state to another. So a state is basically a container for multiple animation clips. So in this case, the idle state contains the main idle clip, the walk state contains the main walk, and you see how they're all interconnected, and they have all these the connections of all these little circle here. The circle means that this transition have a transition clip. With the transition clip, basically you have a smoother transition. Otherwise, Atoms just try to blend straight with blending, like linear blending the clips. So yeah, having transition clips, if you are trying to reach the best and optimal quality of animation, is just better to have. And then there are other options here, but again, I would recommend to check the state machines video and so on. Then we have the behavior modules and the behavior trees. And we're gonna, for the behavior trees, we just made a long set of videos explaining how the behavior trees work, although we're gonna check an example later. And then in the behavior modules, here you can, here you have all the default behavior modules that are available within Atoms, but you can always create new ones with Python inside your scene if you want to achieve like a different behavior that is not the one that, that is not achievable with the standard behaviors that we provide within Atoms. Okay, so this is the Atoms UI. Then, okay, so basically now we're all set up. One thing that I forgot to say is like if you create a new animation clip, you can define if you want to use script or GUI mode. Most of the times you would want to use a GUI mode. You see here, like at the moment the path is pointing to something that doesn't exist, so we have the red icon. You can edit this stuff here, so let's just provide this path here as well. And once you provide it, you can just click register, and now this clip is available. So you can use it in a state machine or within an agent group. And the same thing is valid for the agent type. So whenever you create one, you'll see that orange border showing. You can click register, and then that basically will register the new agent type within your scene. Same thing again. You see we have the same button, add remove in all tabs. Okay, so now we can start, creating our simulation. So what we'd have to do is you would have to create one or more agent groups. So agent groups, they act as containers for agents, and all the agents, they will share pretty much the same behavior depending on how you set up your agent group. Whenever you select an agent group in the attribute editor, you will see these widgets showing. So here we have a list of behaviors, and we're gonna add some later. Here we have the options of the behavior, the selected behavior. Then here we have some settings, some buttons that are useful for clearing the selection or selecting some agents in the viewport. We have our new debugger, and we have also the draw metadata. So let's just explore briefly how this all works. So when you click add, you can add now a new behavior. So the behavior list will be evaluated in a stack. So here now I've added a grid layout, which is like the basic layout. Whenever you check our videos, you see that we use a grid layout or even other layouts, but mainly a grid layout because it's super quick to do. And if you want to run some quick tests, it's actually a great tool for, a great way to lay out your agents quickly. You can provide here an agent type or one like by default, but you can always override the agent types for your agents. So here we can say, let's say we have a grid of 5 by 5. So you see already we have created a grid of 25 agents. You can change the direction, the spacing, and so on. All of these parameters, they are described in our documentation, so feel free to check it. And whenever you see this button here, it means that this parameter is overridable per agent. So it means that, for instance, if I select these agents here, I can set a different direction. So at the moment is 1, 0, 0. I'm gonna say to 0, 0, 0, 1. And you see that now my agents are actually facing the z-axis as opposed instead of the x-axis as it was before. So this is basically what I meant before, as the agents will share pretty much the same behavior, because you can actually override the behavior of the agents, one by one if you want. And now I'm gonna also add a state machine. So a state machine is basically this module. What it does is actually build the state machine for these for the agents using the at the moment it's just the man, but for all the agents we'll try to find the state machine of the agent type for that agent, which is like in this case is the man local state machine. And if we go in the state machine, it will build this state machine in memory for each one of these agents. So now at the moment we have the state 0. If you're wondering what this value is, you can always go again in the Atoms UI, you start selecting the states, and you see here this ID. And that ID basically is a value that defines the state. So at the moment it's 0 here, then we have the walk, which is 1, the jog is 2, and the run is 3. So we just said the walk is 1, so if I just set this to 1, we see that now all the agents are walking. For instance, if I want these agents to be in idle, I can just set it to 0, and if I press play, they're just walking like that. Okay, so again, this is the state machine. There are a lot of attributes here that it's best if you if you just check them on the documentation or other videos, because it's way too much to go through all in one video. One very important thing to know is that even though if you like you see all these attributes here, they're actually my attributes. So if you go down in the extra attributes section, you will eventually find them. So you will see Atoms grid layout, you see seed, the size. So this was actually the size of our grid that we defined before, and so on. So this for the state machine and so on. So this basically means that if you know Python, if you want to build these agent groups with a script and so on, you can do that, and it's it's completely within the Atoms workflow. So you can create agent groups and then set the attributes with the Python script. Okay, so let's go down here. We said we had the settings. So here you have different visualization modes. So we have the skin. Let's enable the textures. Also here we have the variations. At the moment we can't use them just because we don't have any variation. Before we had the skeleton visualization. We have the mesh as well if you provide any proxy geo, although please note that the proxy geo is deprecated and it will soon be removed from Atoms in next versions. And then we have other buttons here. So one is the agent selection tool. So for instance, if you click on that one, you'll be able to select agents. And this is particularly useful, especially if you have, like, for instance, if you are overriding the values for different for the agents. If you select, instead of just going here and selecting the rows and not knowing actually which agent is what, you can select the agents with the selection tool, and then you can provide a value here directly. So this again is pretty useful for setting values on the agents. And then we have so we can clear the selection as well. If you go to a frame and then you click on reset current frame, it will actually resimulate everything for you. So let's say if you changed anything here and you want just to resimulate to see what your change did to the whole of the simulation, you can press that and it will actually resimulate the agent group for you. We have the debugger. The debugger is basically is something new that we adjusted in the Atoms 4, and this is basically showing you two tabs. So we have the spreadsheet tab, which is showing you all the metadata for an agent at any given frame. So you see here the position is changing, the direction is also changing, I think. Let's see, is the direction? No, sorry, this is the velocity. Actually, sorry, the direction it will be constant, but yeah, the velocity is changing. And then we have the Behavior Tree tab, which we're gonna have a look later. And then one final thing is the metadata. So you already heard from me this metadata name, like this, what are these metadata? So I would recommend to see the overview video that we made previously, explaining what metadatas are and how agent groups work and so on, just to also know better how what the behavior modules do and so on. And but the metadatas basically are just custom data that is attached on each agent. So some is attached by default whenever you create an agent. Some other is created by behavior modules when they are created. You can even add your own. You can even add metadata by yourself if you want. Or if you want, like you can create Python script and so on. So metadatas are basically this data that is attached on each agent. So let's see, for instance, if you go here, this tab here, this part here of the UI is pretty useful because you're able to debug, to see actual value of the metadata during the simulation, instead of just looking at the spreadsheet. If you want, you can actually see them here already. One very important thing to understand is like what is a group ID. So the group ID here, you'll see basically we're just showing the group ID as text. You can even have different visualization, but it doesn't make sense for the group ID. So for instance, you can see things as a line or as a circle. For the line, it's mainly useful for the velocity or maybe the direction. The group ID is basically the local ID of this agent within the simulation. So if you have another group, so let's just duplicate this one for a second. I'm gonna press W like this. Okay. So you see here now we have the two different agent groups. I'm gonna activate the draw metadata here as well. Sorry to rewind, and you see basically here that they share all the same group ID. So this agent here, which is like group ID 4, this other agent here has group ID 4 and 9 and 14. So you see they're the same. But if we show the ID instead, which is like the global ID, you see here this one has 4 and this one has 29. In fact, like this ID is actually a global ID on the simulation. So whenever you want to do something to an agent within a group, always use the group ID. And also it's important to know that this group ID, for instance, is also the if you go again in the override dialog, this value is actually the same value as that we see here. So it's basically the index row here. Sorry, the row index. So C4 is actually that one. We actually selected that agent there. 2 is that one. So if you want even just to see the group ID here and browse the override dialog just to set overrides, you can always do that. Okay, so this is like a brief introduction about how you can use the grid layout and any agent group. Let me just show you quickly the points layout, and then I will just move to the scenes. So for the points layout, we have I'm gonna create a state machine. So the points layout is a layout which will let you create agents in a more like artistic way. So now I'm gonna select that guy and I'm gonna start placing agents. Let me just go back to the attribute header and change this to skin, so we see the skin instead. So you can place agents instead of just having a grid or having maybe scattering agents on a mesh. You can always just use the points layout. You can rotate a grid or even a single agent whenever you have the agent selected. Then you can use different distributions if you want. And then whenever you have laid out any agent, you can always select them, and move them if you want, or even, rotate them. You can even use different mode for rotating and, and moving. And also for the scale, you can, just scale them according to their position. If you use the local mode, it will actually apply a scale. But we're gonna have a look a little later to the points layout, so to the layout tool with other scenes. But yeah, like this is the points layout. This is how you can actually lay out your agents in a more like artistic way. And then if you want to use the same workflow as we did before, you can always go here and just say, okay, I want the state to be different for this one. And finally, one thing that I forgot to add before about metadatas. So here you see that we have the state machine that is setting the state on the agents. Whenever you change this value, you're actually changing the state metadata on an agent. So if we actually go for that agent group and we go in the draw metadata, we can see that if I show the state, show them again. You see basically these are actually the values that we set up here before. So the state machine is actually setting that metadata so that basically the state machine operator, which is running under the hood in the dependency graph of each agent group, of each agent, will get that value and then set the state for the agent. One way to override this is also using custom modules or even another metadata. So for instance, if I say state, we know the state is an integer. So you see, as soon as I set it to int, we have actually overwritten every setting that we had before in the state machine. And this is because now this metadata that comes after, this other metadata module which comes after in the stack, after the state machine in the stack, is setting the value to 0. So now if I want to set it to 1, for instance, and now all the agents are working. You can still override this value per agent and so on. But this basically is just to make you understand that you can actually change the metadatas of the agent even with, in ways that, as I said before, like with Python scripts or even modules, even our modules and so on. Okay, so this is all for the first part. Now let's have a look at the demo scenes. Okay, so this is like the first demo scene. You can find this one in particular even in the demo folder of your AtomsMaya installation. This scene is just to show you how the foot locking works. You remember before we said that the man has already the leg properly set up for the skeleton, and also we have all the foot down state for all the clips already set up. So in this case will be just the work. If I press play now, you will see how our foot locking and terrain adaptation works. We have soft decay and stretch in the applied on the legs, so just to make sure that the animation quality is good enough. And you see that the agent is completely adapting to the terrain. So it's like it's going uphill or it's going down a slope and so on. So basically, yeah, this video is just to show you how our the foot locking and the terrain adaptation works, and also the animation quality, of course. Now let's have a look at the second one. The first scenes are gonna be pretty boring, I tell you already, but anyway, just to show you, this is basically showing you how you can use an animated eye field. So actually, I didn't explain this before. Let me just show you quickly. If we have create an agent group, and very quickly we create a grid layout and a state machine, and let's save the grid layout 3x3 and a state machine to 1. Let me change this to skin. Okay, like that. So we have the agents working on a straight line, nothing too exciting. If you create a plane like this, for instance, then we just scale it. And let me change the sections. So let's say 100 on 100. Vertex. Okay, something like this, something pretty quick just to show you. So you see now the agent, even if you press play, they're just going into the ground and they just ignore completely the terrain that we just placed into our scene. So what we want to do is, like, we want to go in the eye field manager, we want to select that mesh, click add, give it a name. Usually I always give HF just because it's quick and simple. You provide the mesh that you want to use. You can provide multiple meshes, and you can provide even different grid modes if you want. And you can also here say if it's animated or not. So in the case of that scene with the ground moving in that way, deforming in that way, not moving, you would actually have to tick that option, because otherwise Atom will just use the terrain at the first frame, so it won't refresh it at every single iteration. If you press play, still nothing. What you have to do is you have to go on the agent group, on the state machine module. Here you can provide an eye field. So I'm just gonna say HF, and you see as soon as I put that value there, of course you can, we have here a list of all the available eye field. You can press play, and now the agents are adapting to the ground. So this is basically how eye fields works. So just go back to that scene quickly. So if I open the eye field manager, you see we have the eye field there. You see this option is on, and this is why the agents are actually adapting to the terrain, even if it's deforming. Otherwise, if it's just a static terrain, just don't even think about checking, activating that option. Just leave it off, and Atoms will be much faster. Okay, so then we have the 3D eye field. So Atoms works with standard eye field, so it can be a terrain in 2D, the 2D terrain, you know, like just a plane. But Atoms can also adapt, agents to 3D meshes like this one. We can even have different, more complicated terrain if you want. And to do that, you will have to provide both the eye field, but also the gravity field. So the gravity field will tell Atoms where to pick the normal for your agents. So in this case, it's just picking the normal of this mesh and just applying it as the up vector of the agents. And basically now they're following that, the shape of this mesh. If you have, like, for instance, a bumpy mesh, you cannot use that as a gravity field. You would use that as a height field, but then as a gravity field, you have always to provide the smoothest mesh as possible, because it's important how Atoms picks the up vector. So even if you have, for instance, bumps around here, just make sure like the mesh looks like this one, because it's important that the up vectors are actually, pointing towards, toward the outside this like ellipse or a deformed sphere. Okay, so another thing about, again, the metadatas is another module that you can use is called the area trigger. So the area trigger, what it does is, like, you can connect a plane or a geometry. In this case, it's a plane like that one. And then when the plane, the agents are within that plane, so you can say if the plane or the mesh that you're providing should be treated as a volume, or it's just gonna be a plane, and then you can just project the intersection of the agents on that plane, like in this case, because we don't have the as volume on. Whenever the agents enter that area, you can change a metadata on the agents. So in this case, we're changing the state, and we're making like this wave on the happening on all the agents. Here is another example. You might have noticed whenever I clicked on the add button that here we have different categories. And in particular, now we are gonna check the pose category. And these modules, what they do, they actually change the pose of the agent that within this agent group. In this one, for instance, we can provide for this IKM module, we can provide a root joint name, a mid joint name, and IK joint name, which basically what Atoms will do, will create on the fly an IK for this joint chain, and then it will try to make sure that the IK joint is actually trying to reach, the aim position. So if I press play now, you see that the agent is actually, the arm is the wrist is actually trying to reach that locator. You can, of course, also use different modules. For instance, another one is called the joint transform, which works in conjunction of the joint transform tool. So you can select joints. For instance, I can select that one and then rotate them like that. Then let me check. This is the angle. Yeah. And then if I press play, you will see that what we have done was just applied some offset to the animation of the agent. What basically happened under the hood whenever you were rotating those agents? We added these two joint transform modules, and these two basically they had they set overrides for each agent that you modify for the joint, and provide also the values that you have just applied in the viewport. So in this case, like the rotation for that joint, and then the other rotation for the other joint. So let's go to the next example. We have so this is an agent avoidance. Here we have, as for any crowd, that you want always to make sure that the agents don't overlap. So we provide an agent avoidance with different methods. I would recommend always use RVO or PETVO, just because the timed collision doesn't work well whenever you have packed and condensed area of the agents. Then we have an agent separation, which makes sure that the agents push each other away whenever they're within a certain distance. And then we have the proximity metadata, which is another metadata module that In this case, we change the state to 0, so it means that the agent will stop whenever they are closer than 100 units. So if I press play now, you will see that some agents will stop, some other will just try to avoid each other, and then they will start again working after a while. So this is a way in which you can set up, avoidance between your agents. The proximity metadata can be used for a number of things. Of course, changing the state is one of the few purposes that comes straight to your mind. Depending on how you set up your parameters. So, for instance, the one important one is called the site. So the site, the closer is to 1, the narrower is the cone angle of view of your agent, and the closer is to 0, the wider is that angle. So if it's at the moment it's 0.3, so it means that each agent can see pretty much everything that's happening in front of it. So you see this agent just saw that agent and then it stopped, then it saw this other one and then it stopped, and then it can keep going, and you see this chain reaction where these agents are stopping and the other one are started working again, and so on. One thing to know is that we also have this attribute which is called avoid mutual effect. That what this will do will actually make sure that if one agent is affected by another agent, then that same agent, the other agent cannot be affected by this agent. So again, this is why they stop, and then one of them stop and the other one keep walking, because because this option is on, they cannot affect each other. Okay, so then we have the hero promotion, which is a feature that will let you retarget an animation from an agent onto a rig. So here we have our this group of dogs that are just running, and we want to retarget one of them onto a rig that we have here in the scene. So what we will do is we will export an FBX for one dog. I'm gonna select that one, just there, and then call it dog run. So we exported that FBX. Now what we're gonna do is we're gonna go on the tools, retargeting animation, wrong one, tools, retargeting, animation rig retargeting. We're gonna go on the retargeting tab. This is already set up, but what you should do, you should select anything that any control or the group of your rig, and then click in space from selection, select the file, like that one, and then click run. And what this will do is Atoms will retarget that FBX onto your animation rig. In this way, you will be able to then pass this to an animator, and then the animator will be able to animate on top of whatever animation was coming from the crowd. The animation won't be matching 100% between the rig and the agent, but anyway, the results can be pretty accurate, and there will be a great starting point for an animator. Okay, so then we have a behavior tree. So the behavior tree has been already explained in other videos. We're gonna even make more in the future so that you have a better understanding about what's going on. With the behavior tree, what you can do is you can create conditional behavior. So you can say, if this condition happens, then my agent should do this, and then they can go, it's not just one condition, you can stack conditions and so on. In this case, what we have done is we have the agent following this curve. When it reaches this plane, then it stops being affected by the curve, and then it tries to reach the locator, and when it's reached the locator, then we tell the agent to just stop. The behavior tree is defined in the Atoms UI here, and you should have this example also in your demo folder of your AtomsMaya distribution. And then we have here in the behavior tree we provided the name, and then we also set up all the attributes that were needed by the behavior tree. So whenever you select the behavior tree and you expose the parameters, so like the mesh translation and so on, to Maya, then you will see the attributes appearing, and then you can start connecting these attributes with respect to the mesh that we're using as a trigger, to the target position, so we're using the locator position to be the target, and so on. Then if you also want to see what's going on, we always have the debugger. So let me just move this one here. And the debugger, what it does, it actually shows you the current state of the tree and what's going on and where the tree is at every frame. So you see, until it reaches that plane, we're always going into this branch here. And then finally, as soon as we enter that plane, then it goes here, and then we go through all the way down to here when we reach the idle. Sorry, when we reach the locator, sorry. Okay, so now the rendering. For the rendering, the standard process is always to build your simulation, export a cache, export your variations from another scene. We have also videos for explaining that workflow. And then you would create an Atoms proxy in the same scene on another scene where you have the cache and the variation JSON on the proxy. Then in this way, you will be able to render with Arnold, the renderman, and so on. In this scene here that I'm showing you, where I have two optimization on. So we have the instances, use instances and first on calling. With the use instances, Atoms will try to see if any agent has the same variation and same pose, and in that case, it will actually instantiate that agent instead of creating it twice. The same mesh, sorry, not agent, but the same mesh and materials and stuff, instead of creating them twice. And then here we have the first on calling, which basically what it will do is like if we connect your camera to this proxy, it will actually not render all the agents that are visible in this so that present in this scene, but just the ones that are visible. So now I'm gonna click render. Here is this a previous render that I did. And now because of the optimization, the render time will be faster than compared to if you didn't have those attributes on. So this is the final render. Okay, so then we have the cache reader. So with the cache reader, again, the workflow is simple. So you can create an agent group, you can cache it out, and I'm gonna show you just after this scene how to cache it out. And then once you have your caches, you can create a cache reader and set the cache on the agent group. Then if you press play, basically you can see the cache, but you can also edit the cache. So you can create a new height field if you want, like we did in this case. So we have a height field and the agents are adapting to that new height field. We have we can rotate them if you want with the agent layout tool. We can also resimulate them. So if you have a curve or anything else, you can make sure that they actually follow that curve. If you do anything like scaling the agents or applying a follow curve and things like that, if you scrub the timeline, you see that some agents, if you go back and forth, will do weird things, and this is because we are actually resimulating those agents. But for instance, for this agent group here, where we don't have an agent scale, or we haven't scaled the agents, and it's just we're just applying again the cache and then just doing a new ground adaptation. If we can scrub without any problem, and even if for all these other agents, we don't actually have any problem playing. But if you play anyway, the simulation will look okay for all of the agents. Okay, so let me show you quickly how you can cache out an agent group. So I'm going to create a grid layout once again with a state machine. Grid layout is going to be 3x3. Let's do 5x5 just to make it a bit bigger. State, let's do state 1 and skeleton skin. Okay, so what I'm going to do now is I'm going to do export cache exporter. Here you can select one or more agent group that you have in the scene and just take them on the right side. Here you can have multiple agent groups attached to one cache, or you can even have multiple caches being exported at the same time. So what I want to do now, I want to export them in here. I want my start frame and end frame are basically the frame range of my scene, which is okay for me. Then you can also define an action after export. So in my case now I want to just make sure that I want to have like an Atoms group and with a cache reader reading this cache that I'm exporting. Or you could use just an Atoms proxy. But anyway, I'm just gonna use that. Here we're exporting the cache. And if I rewind, now we see this new agent group. The other agent group has been hidden. Let me change this to skin. And now I can scrub because this is a cache, and you see that the agents are actually being animated as the previous simulation. So anyway, your agents could have been doing other things, of course. But anyway, now then you would have cached them, and then you would have the same exact result. So you would just see the same simulation that you had before in your Maya scene. Then with the agent layout tool, I'm gonna activate it. You can start, modifying this cache. So for instance, I can select these agents. I can rotate them like that. Sorry, this. And if I press play, the agents are working in the new direction that I've just assigned. You can even change this direction at a different frame, and Atoms will still, work. Okay, and you can change the position, the scale. You can even change the time offset. So you can time offset the agents. So if I press play like that, they will be like that. You can also duplicate, of course, agents. So if I select these agents here, and I do Control D, and I do Control D again, Control D. This is what you get. So you can, with the agent layout tool, you can manipulate the caches as you want. Let me open a new scene. So cache reader collision. So again, with the proximity, this is just another example with the proximity metadata module. What we have here is we can have multiple proximity metadata working on the same agent group. So this scene is pretty simple. So we have these agents running towards this other, this army, let's say, running towards the other army. And what we have done here was just make sure that some agents will look scared, so they will start working backward, and then some other will just get to the block position, and then they will, they will all die eventually if they get close to the attacking army. So to do that, what we have just done, we just changed the state to to certain values. So in this case, we did 3. But it could have been for other, we set 5, which is like, I think is the walk backward. Yeah, the walk back, and then we have the block, which is 3. And then eventually they all go to death anyway. So the other proximity metadata will go to, basically set the state to 4 whenever they get close to the, whenever the agent, the attacking any agent from the attacking army is that close to any agent of this army here. This is just to show you how you can use the proximity metadata in a different way as well. So okay, then we can also use Ragdolls if you want, for army scenes and so on. So here we have some archers throwing arrows to these agents, sorry, these knights here. And whenever an arrow is gonna hit the agents not on the shield, they will just die. So for this one, what you have to do is really you have to start by creating a ragdoll setup, then apply that ragdoll setup on the knight agent type. And then once you have the knight agent type, actually I think it's called soldier, but let me check. Yeah, the soldier agent type, you see here we have a ragdoll setup. Then you can start using these sort of simulations. Here we have an agent group for the archers and another one for the arrows. So this is how you set up the arrows in Atoms. So we have a specific tutorial for this one. I will let you check that, but just to show you, this is also another thing that you can do with Atoms if you want. Okay, so then we have this one, the training scene. In here, a few things are happening. So the first one is we have these archers here, and you see that the arrows are getting stuck on the on this mesh here, although it's rotating. And this is because we have a night field applied on our field on our emitter. So whenever we have a night field there, basically whenever the sorry, I was playing backward instead of forward. Whenever you have a night field, you basically the arrows will get stuck on that night field. Then we have an agent group simulating. This agent group instead is just a cache reader with some agents that are following a curve. Here some agents just doing let me check, this is like the combo. Yeah, it's just playing a clip. But the interesting part of this scene is this one. So here we have the we have some agents from an agent group, which is called the slash group, that are working, and then as soon as they enter this area trigger, so we have this mesh here, which is this mesh here, they will start, they will enter in the state, which is the sorry, the state is state, what is it, int value 1. So you will enter into this state and they will start slashing. Instead we have this other group, which is called the block group. They are in a state which is state 2. Then when the other agent is getting close enough, so close of let's say 350 units, they will switch to the state 3, which is like, you'll see that now they will go in the block position. So they will wait for the sword to just hit their shield. And then once the sword hit their shield, they see that they play another animation. So this is not actually a procedural animation as you might think, but it's actually a different module that has been written in this scene. So before you might remember that we said that you can create behavior modules directly in the scene, and this is what we have done here. So if you know Python, you can really do a lot of crazy things with Atoms, because you can write a custom Python script here, register it, and then you will find it straight away into the behavior module list. Then here you can provide any kind of, by exposing attributes here, you actually are exposing attributes in Maya. So you can pass stuff from Maya to this behavior module. And then in the methods that are being called during the simulation for this module, you can do different things. So in this case, what we are doing really is like, we are getting this agent group, which is the opposite agent group. So remember this slash agent group. If the distance between these two joints, so this is like the shield joint from this agent group, so the block group shape, and this joint from any agent from the other group, which is the slash group shape, is closer than 70, then we play this state. Otherwise we just and then we go back to this other state, so state 3. And all of this code here is just doing that. I mean, it's not much code, but like this stuff could have you could have done it with standard Atoms, but you can do it with a custom script. So okay, so anyway, if you know Python, you can unlock a lot of potential with Atoms. Okay, so we have the large vignette example. This example, what it does is like we have a large scene battle where we have a lot of agent groups and they're all reading the same cache. And what we have done here, we have just rotated the cache into the scene. We haven't even time offsetted it, but you could have done it if you wanted. And then if you press play here, you see that the scene is going pretty fast, and it looks like the agents are pretty much doing something differently, although if you're very careful, you'll see things repeating in this scene. But this is a way in which you can, lay out, create a scene pretty quickly with a very little effort. So you can just build a cache and just replicate it, and then start duplicating agents around, rotating, moving them, and so on. And then you would create that sort of randomness that will make your shot look as it is, like as it was, like every animation was different. Okay, so the last one is another vignette scene, but this one is a bit different because we have different caches being played. And it's if you notice it, when I press play, now if you have like a lot of caches and they're very heavy, the first time that the timeline plays, it will be slow, but then the second time it will be much faster. And this is because We have something running in Atoms which is called the cache manager, which if I go here and you go under cache manager, you see here we have 3 caches. You can remove the caches. Let me remove clear all actually, and then if I rewind and press play, actually it's still fast, but anyway, if the caches are quite heavy, then it would actually take time to recache them during this timeline, during the length of the timeline, and then the second time the timeline would be faster, would be much faster. In this scene also we have other things going on, like we have 2 agent groups, so with these 2 agents going one towards another, and then these other soldiers coming towards, approaching the where the battle is taking place. Okay, so this is all for this demo of Atoms in Maya. I know there are a lot of things that we haven't touched, but again, we have other videos and we'll make more in the future just to explain how Atoms works in Maya. And if you have any question, again, just feel free to send us an email, or even better, write on the Google group, and we'll make sure to reply as soon as possible. Thanks for watching. Bye-bye.